So example 4 has a bunch of different graphing. The one in particular that we're going to be focusing on, or just because it's the most different, is in C, where we've got a plus D. Can you see in C there's a plus 3? And that, any kind of adding at the end of the function, that shifts a graph up or down. So we're going to look at how that affects our graph and what in particular, sort of everything we've done so far for our sine and cos graph has done something particular. So A, that affected our amplitude. That's particular to sine and cosine graphs. B affected our period, and that's particular to sine and cosine graphs. And then using the amplitude and the period, when we went to a phase shift, which was our C value, we just said if we know where our starting point is, then we can draw the rest of it. So our C value affected our starting point. And now we're going to look at, when we get to part C, what does our D value do when it relates to our graph. So, part A, it says, how does that relate to the graph of sine x? Well, this is going to be a vertical stretch by a factor of 3. What does that do? That means the amplitude is 3. Right here above, I'm going to graph our sine graph again. So our sine graph has a period of 2 pi. Notice the pattern that we always do. We start with our period and divide it into 4 sections. Then we label our amplitude, -1 and 1. Then we say, where do we start? Our starting point is, for a sine graph, in the middle going up, and then you can go up, then back to the middle, then down, then back to the middle again. And there's our regular sine graph. So for part A, what is the graph of 3 sine of x going to look like? Well, it's still going to have a period of 2 pi. So we can start with that, split it into 4 equal sections. Then label our amplitude. Well, now our amplitude is 3. So from the middle, we're going to go up to 3 and down to -3. Where does sine start? Sine starts in the middle going up, so now the maximum's up here, back to the middle, down to the minimum, back to the middle again. And there we have the graph of y equals 3 sine x. For B, B was y equals sine 3x. So now the 3 is where the B value is. That's our horizontal stretches and compressions. So as a comparison, this one is a horizontal compression by a factor of 1/3. As far as how that relates to the special things about sine and cosine graphs, this means that our period is going to be 2 pi over 3. Again, that formula, that period is 2 pi over your B value. You can either do it by saying, I know my original period was 2 pi, a horizontal compression by 1/3 would change it to 2 pi over 3. Or I can use that formula that says, my period is 2 pi over the B value, and since my B value is 3, my period's going to be 2 pi over 3. So how do we graph this? We mark our period, but now our period instead of 2 pi is 2 pi over 3. Divide it into 4 equal sections, I always start with the one in the middle because that's half of 2 pi over 3, which will just be pi over 3. Then I go to the one and cut pi over 3 in half, and that'll be pi over 6. And then for the third one, I count by pi over 6s. 1 pi over 6, 2 pi over 6. This one will be 3 pi over 6. Now 3 pi over 6, if I wanted to reduce that, I could write it as pi over 2, or you could write it as 3 pi over 6. Our amplitude is 1, so we go up from the middle to 1, down 1 from the middle. Our sine graph starts in the middle going up, so now that you've got your 4 equal sections, you can go from your middle to your maximum, to the middle, to a minimum, and back to the middle again. And the last one was looking at what would happen if we had sine x plus 3. If we were describing this, this is a vertical translation. Three units up. And what does that do in particular to our graph? The middle, which is called the average or the center line or the sinusoidal axis, it started at y equals 0. It was a horizontal line at y equals 0. Now it's going to be up 3, so it's going to be a horizontal line at y equals 3. So what does this look like? We're going to find when we have to combine all of these, we're actually going to start with our d value, which is kind of counterintuitive because if you think about our translations unit, we always went from left to right. So if you went from left to right, you would hit A, then B, then C, then D. But as far as a shortcut goes for sine and cosine graphs, your translation will always affect your center line. And so now that my center line is at 1, 2, 3, we're going to actually start with that and label a dotted line for a sinusoidal axis at y equals 3. Can you see in this one that your amplitude is still 1? Our definition of our amplitude is from the center line up to the maximum and down to the minimum. So now that my center line is at 3, if my amplitude is 1, can you see that my maximum value is going to be at 4? And my minimum value is going to be at 2. We can label our period. This one has no b value, so it starts with a normal period of 2 pi and split that into 4 equal sections. And then we ask ourselves about our starting point. Where's the starting point for sine? Okay? And this is where all the way through in my language, I haven't said it starts at the origin. I haven't said it starts on the x-axis. Every time I've talked about it, and you probably haven't noticed, but I've always said it starts in the middle. So where's our middle? Our middle now has been moved up, because our sinusoidal axis is our middle. So our starting point is in the middle going up. There's our middle. Then to a maximum, back to a middle, down to a minimum, back to the middle. And this is what the graph of y equals sine x plus 3 looks like. I mean, it should make sense because we're just taking our original graph and moving it up 3. But as far as the way that we're going to combine all of these things together as sort of a shortcut for graphing sine and cosine graphs, we're going to start by labeling our sinusoidal axis 3 units up. And then think, okay, for a sine graph, I'm going to start at the middle. and then go middle, max, middle, min, middle, over and over again. Questions for this one are 6 and 7.